All right, so I've been doing quite a bit of data logging, and I've been cruising an EVO scan with the data logger running. I think this is a 40-minute log. So the injector scaling, let's get to that. I've learned some things. So I find that reading helps, but also practicing doing things in real life helps me learn. So if you're familiar with EVO scan and ECU flash and tuning EVOs, you know that there's this handy dandy tuning guide by Merlin online for tuning the EVO 10. And there's a whole section on injector tuning and latency. And I kind of brushed on this in some of my other videos. It tells you how to set up your latency per battery volts table, and also the scaling. And there's a lot of examples in here of stuff that's worked for people. The only thing I found lacking was that in this table, it tells you, yeah, injector, what they scaled it to, what type of gas they're running, and what their latency table looked like. But it doesn't tell you anything about like their other parts of their fuel system. Like, for example, I'm running Walbro 450 LPH pump, and my base fuel pressure is a little bit higher than stock. So I found that actually I had to scale my injectors quite a bit higher than some of the examples in here. For example, these FIC 1050s, I'm running not fuel injector clinic, but injector dynamics 1050s. 1008 was not what I ended up at, and I also did not end up with these latencies. So when you go to Injector Dynamics website, they have their own table that tells you based on the fuel pressure that you're running what you should put in, and I found that even that didn't work the way I thought it would. So there's a couple things I learned while doing this. You can follow directions in Merlin's guide, and they're pretty accurate. The steps you really want to pay attention for is when it tells you how to like actually tune the injectors. When you get down to the long-term fuel trims and the short-term fuel trims and understanding how they work and how they add together, that section is very critical. But the big thing I learned is that on the tuning, let's say for example, we're looking at low idle long-term fuel trim. Let's look at cruise. Takes a second to come up because the log's so big. So I was running a lot in this area, this 1.6, 1.8. You can see, let me not highlight over it. 1.6, 1.8, 1.8, 1.4. That was the area my cruise was on the highway. So it's adding 1 point something percent fuel, whatever the table says, plus whatever the short-term fuel trim happens to be in that box. So let's highlight those real quick. It was right around here. So you can see in those boxes we're adding 0.3, 0.4, 0.6, 1.3. So if you add those two together, that's the percentage of fuel it's adding, right? Now it takes 4 minutes of a short-term fuel trim to actually start incrementing the long-term. So you have to take a long drive at a like steady value to get these to change on the long-term. But what I wanted to say was when you're doing the actual map changes, so like for example you're in ECU flash, you're typically messing with your injector sizing and your injector latency curve. The injector latency curve doesn't affect your cruise trim as much as it affects your idle trim. So like shifting this up and down doesn't have a big impact on cruise versus idle like you would think it does. It's more on idle. And the reason is because at idle, like if I were to go back to my log and I look at my injector pulse width, right, when it comes up. So down here in the idle areas, you can see we're running somewhere between 1.4 to 1.7, right, on our injector pulse width. That's in milliseconds. So when you start getting into these areas where we're cruising, we're running, you know, anywhere from 1.8 to 2.1, et cetera, right? So we're running more fuel in milliseconds. It's opening the injector longer at cruise than it is at idle. But when you go look at the table for injector latency compensation per voltage, you'll notice it's in milliseconds, right? So when I'm only using 1.4 seconds, milliseconds of fuel time on time for the injector, if I add whatever the latency the computer expects it to be at idle, if I add another 0.5 milliseconds, that adds a lot more fuel than if I add 0.5 milliseconds to any one of these other zones in the map where we're not running a small amount of fuel. So basically, the injector scaling is proportional, right? But the latency is not. It only depends on voltage, and your voltage isn't really changing that much. So when you change this curve, if you shift it up or down, it's going to have a much higher impact on your idle long-term fuel trim than it does on your cruise fuel trim, just because of the nature of how much injector pulse width time it takes. Because remember, this table basically just tells the computer, well, you need to turn the injector on this much earlier, this much longer to get the fuel flowing at the amount that you're trying to meter in. So this is just a scalar essentially, or it's not a scalar, it's an additive, whereas the fuel injector size is a scalar, so that's based on, how much percentage of fuel per pulse that it expects. So that helped me a lot to understand what I was doing, because when you're looking at these two fuel trims, you want to get them, the long-term idle and cruise, you kind of want to get them close to each other, and that tells you that your scaling's somewhat close, but you also want to get them less than 5%. So what I noticed is that you probably want to tune the cruise first. I mean, you want to check the idle just to see that it'll start and make sure that you're close. But for actually doing the actual fuel injector scaling, your cruise is going to tell you a lot more about how close you are. And in my case, the data log was showing that my cruise, I'm adding about 1.6, 1.8% on my long terms, and on my short terms, when it comes up, I'm subtracting, I'm adding. So my short term is very steady in that area. It's not really moving, and my long term is very low. My long-term fuel trim at cruise is very low. If it'll flip over, come on. Okay. So you see, I'm just adding a tiny bit. That's a small percentage of fuel, so it's pretty steady. So I'd say my fuel trim's pretty good. So really, I'm probably not going to mess with that too much. And the only one I'll mess with is moving the curve, because you see I'm still taking fuel away here. So in all my idle ranges, I'm still subtracting a lot of fuel. Not too much. I mean, really, 6% is not that much. You still have to add in the short term. So we're adding a little bit. So it'll slowly come back to zero. It looks like. But this is pretty close. I'd say this is pretty close to drive around, just normally, as long as the rest of your map's okay. But yeah, I mean, I need to basically go ahead and shift this down. So what I'm seeing is that the idle trim is still pulling more fuel, whereas the cruise trim is pretty steady. It's almost at zero. But the idle trim's pulling fuel, so it still thinks it's too rich at idle. So what I need to do is just take a little bit more injector on time out by shifting the latency compensation per battery voltage curve down. So I mean, you just basically want to highlight all the cells and press the subtract minus button on your keypad. That'll shift the whole curve down. That'll subtract more fuel at idle than it's going to subtract at the cruise. If it does take too much at cruise, then you want to go back and up this injector scaling number and redo the whole process. But you can play with it forever, basically, is what I've heard, and you'll never get spot on. So most people try to get within 5% plus or minus on the long-term fuel trims and then leave it. So anyways, I think we're pretty close. The other thing I noticed, and this is just a general comment on my tune, is that I did a couple pulls after I was pretty confident that it was running good, yet the long-term trims were good, and that my wideband, I would do some partial throttle pulls, get a little bit of boost, just to see what the fuel ratios were. So I did do a couple pulls in the same log. So up in here in these ranges, it was pretty good. You can see I peaked down here at 26.8 psi. It's on a stock turbo. But I have also logged my wideband, which I have input through the rear O2 port on the car. So I scaled my analog output on my wideband 0 to 5 volts. to output on the rear wideband, the rear O2 sensor, and then I log it over the Tactrix cable. And you can see here, I've got pretty much my cruise AFRs are right. They're averaging in the mid 14s, right? And then, come on, if you can see, this is like the spool up area, so we're in the low 12s, which is not bad because you don't have to have full 11 something for spool up. You want to have a little bit lean. But then when we get into full boost over here, in this part of the map, we're running 11.3, 10.6, 11.1, and it's really rich down here. Now you can see this is the map I loaded that I actually have on the ECU. And it's really rich down here in this top range. And you can see if I highlight, let's say we go to this cell right here, okay, and then hover it over it, you can see wideband says 10.6, interpolated calc said 11. This is at 10.7. If I go here, I think it's even worse. So when I say worse, I should be running 11s, right? But what's actually happening is what's actually on the map is pretty much close to what I'm getting on the wideband, which is good. But what that tells me is that in my original setup, when I had the stock injectors, stock fuel pump, I was probably maxed out on my injector duty cycle here, and I was just kept adding fuel in this part of the table to try and make sure I had the right AFR. Because I remember when I had this tune originally, you know, it was more like mid 11s in this range, not in the 10s. So now my fuel system's been beefed up. Now I've got more injector, I've got more pump. And like if I go look at my, there should be injector duty cycle. Yeah, here we go. If we go to injector duty cycle on my map, here's what got reported out. So peak injector duty cycle was in the low 60s. So I'm only using 60% of my available fuel at high boost. And I'm running rich even, so this is going to go down. So basically what needs to happen is, the way I was running the stock system, it was probably struggling hard, and that's probably why I lost my last motor, because that tune and that motor had 90,000 miles on it. Chances are the injectors were not up to snuff. You know, the pump was starting to get old. Just, it could have been a number of things, but eventually, from doing that, I probably cracked the piston, just ran lean that one time because I was always on the hairy edge and I didn't have enough fuel one time, and it could have caused damage that just went on for a while. So now that I've got the bigger injectors and I've got the new fuel pump, I can see that I've got a lot more fuel than I need up here, according to the map, the way I tuned it. So I need to dial this back so that my fuel ratios go back to normal. But that's a good thing because that means I have a lot more headroom to grow. And that's a good thing because, well, the next step I'm going to show you in 1 second, because, you know, I didn't just upgrade the fuel system because I thought I needed it, although it's probably a good thing. It's because we're going to do some awesome stuff to this car very soon. So here it is, the next step in the evolution of my evolution. The MHI 18K from Mitsubishi and Force Performance. It's the genuine deal, brand new. And we're going to put in a new cast stainless steel manifold from MA Performance to help complement it. And that was the whole reason I did all these fuel system upgrades, because I wanted to get ready for this. So rather than throwing it all in the car at once, we're going to do this staged. So tuning, getting it running right on the new fuel system was the first step. And then eventually, and I'm thinking probably not until March-ish, we're going to put this bad boy in. For now, I'm just going to get my tune sorted out the way it is, enjoy driving the car for a little while before I take it down for a couple weeks again to do this, because this will take me some time. I like to be thorough. It'll probably take me a couple weekends to get installed, just because it's going to take a lot of stuff off the car to get it out. So tune in. That's the next step. There'll be some other small modifications along the way, but this is where we're going. This is what I think is going to work best for this stock internal EVO 10 that I've owned for, well, 11 years now. Bye.